Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is the 12th video, guys, which simply means I'm doing question number 12. Please do expect a total number of 13 videos where I'm tackling past exam question papers, and I'm only focusing on electrostatics. Even if you're doing grade 11, guys, it's okay. Grade 11 and grade 12 electrostatics is one and the same thing. And the reason why, guys, I keep on doing these exam-like question papers, rather exam-like questions, it's for you guys to familiarize with how to tackle exam questions, because I believe that knowing how the examiner asks questions, it's going to be advantageous to you whenever you write your exam. So please do watch all these 13 videos, guys, now. And obviously, if you still want to learn electrostatics from scratch, there is a playlist for that too. Okay, we are told that two small identical spheres P and T are placed at a distance which is 0.1 meters apart, as shown in the diagram below. P carries a charge of positive 3 microcoulombs and T carries a charge of negative 3 microcoulombs. Okay, we have two unlike charges which are definitely going to attract one another. Okay, so the first question, they want us to state Coulomb's law in words. It simply states that the electrostatic force between 2-point charges is directly proportional to the products of their charges and inversely proportional to the square of the distance apart. The electrostatic force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance apart. Okay, now they want us to draw the resultant electric field. Okay, we have sphere P over there and T. That's T and that's P. They have different polarity, so they'll definitely attract one another, which simply means electrons will be transferred together. There will be a transfer of electrons. Since these two charges are identical and they have the same magnitude, the number of field lines should be the same, né? And since sphere P is the one which is positive, so that means the arrows will point from sphere P pointing to sphere T, né? On sphere P they will point outwards, on T they will point inside, like that. Okay. And then now we are told that a third charged sphere as of unknown charge is placed a distance of 0.15 meters from T, such that the three charged spheres are at the vertices of a right angle triangle. Okay. The net electrostatic force on T due to the other two charged spheres has a magnitude of 10 newtons, as shown in the diagram below. The first question, guys, they want us to state whether this charge is negative or positive. This one over there. Okay, for the fact that, guys, our F net is pointing in the northeastern direction, it simply means that the behavior on charge T due to the other two charges, since P and T are attracting one another, that simply means that T was being pulled upwards by this sphere over there, né? And then now, for us to have an F net which goes in that direction, it simply means that this charge here was pulling T in that direction. And the only way that this charge can pull T in that direction is if the charge on that sphere is positive, because it will attract because it will attract to sphere T. Remember that, guys, opposite charges will always attract one another. Okay, and then now they want us to calculate the number of electrons. The number of electrons added to remove. What's any? Calculate the number of electrons added to or removed from sphere S to give it a charge QS. Firstly, you must calculate the charge on QS, ne? And then go and calculate the number of electrons transferred. How can you do that? Remember that, guys, we were told that the charges are at right angles with one another. So basically, it simply means that this force over here, the electrostatic force, should be equals to the electrostatic force over there. Ne? This will be the electrostatic force between charge P and T, and then over here we'll have an electrostatic force between charge T and S, and that's our F net. If we have a right angle over there, it simply means that we can simply use our Pythagoras theorem to find firstly the electrostatic force between these two charges, and then go and find the charge on sphere T. Let's just do that. Now, I know that F net squared is equal to the electrostatic force between P and T squared plus the electrostatic force between T and S all squared. Ne? I'm looking for the electrostatic force between T and S first. Ne? That means the electrostatic force between T and S is equals to F net squared minus F between P and T all squared. Let's just calculate. We were given F net to be 10 newtons, right? And then that's K. I know that K is just 9 times 10 to the power 9. The magnitude of P, that's positive 3 times 10 to the negative 6. And T is also negative 3, ne? But remember that, guys, whenever I substitute, I do not substitute the magnitude of the signs of my charges. The distance was just 0.1 squared, ne? Remember that, guys, all of this is squared. So whenever I punch my calculator, this will give me 100 minus, or rather, let me just punch everything. 10 squared minus okay, I simply have 9 times 10 to the power 9, and then 3 times 10 to the power negative 6 multiplied by 3 times 10 to the power negative 6 all over 0.1 squared, and the entire thing is also squared, né? So I'll simply get an answer of I'll simply get 34.39. This is F, the force between T and S, but it is squared, right? So the square root of my answer will simply give me the force to be equals to 5.86. Yeah, 5.86 newtons. So this is the electrostatic force between charge T and charge S. Now, since I know the electrostatic force, I can go and find the charge on sphere S. Okay, let's do that. The charge on sphere S, F is equal to K Q1 Q2 over R squared. Ne? I know that the force is just 5.86, but guys, it's not advisable to round off before the final answer. It's 5.864298.765. 5.864298.765. That's equals to 9 times 10 to the power 9. 3 times 10 to the power negative 6. I'm looking for the charge. I'm looking for charge S. The distance between the two is just 0.15 meters. Okay, and then for me to find my charge over here, I just need to cross multiply 5.864298765. This is multiplied by 0.15 all squared, all divided by 9 times 10 to the power 9, and then 3 times 10 to the power negative 6. Therefore, QS is just equals to answer multiplied by 0.15 all squared divided by 9 times 10 to the power positive 9 multiplied by 3 times 10 to the power negative 6. This will give me a magnitude of 4.88, or rather 4.89 times 10 to the power negative 6 coulombs. 4.89 to the power negative 6 coulombs, right? Okay, but they wanted us to calculate the number of electrons that were removed or added. Since our charge it's a positive charge, right? It simply means that electrons were removed. Are you together? So how can you calculate the number of electrons that were removed? Always say number of electrons transferred is the change in the charge all over a unit charge. That's 4.89 times 10 to the power negative 6 minus 0 all over 1.6 times 10 to the negative 19. I'm saying minus 0, guys, because initially the charge was neutral. Are you together? And then for it to be charged, it will either get positively charged or negatively charged. If you remove electrons, the charge will then become the neutral charge will then become positively charged. But if you add electrons, the neutral charge will then become positively charged. I mean negatively charged. Are you together? So since our charge is now positive, that means electrons were removed from its state of neutrality. And then what do we get over there? That's 4.89 times 10 to the power negative 6 minus 0 all over 1.6 times 10 to the power negative 19. So the number of electrons that were removed is basically 3.05625 times 10 to the power 18 electrons. I did not round off this answer. This is the total number of electrons that was removed. The number of electrons that were removed. Okay. And then now we are told that P is a variable point in the electric field of charged sphere A and R. But P is a variable point in the electric field of charged sphere A, and R is the distance between P and the center of sphere A. Okay. A learner determines the magnitude of the electric field at a point for different values of R. Okay. Sphere A is then replaced by another sphere B of a different charge. Another set of results are obtained. The graphs below obtained from the results for the results for sphere A and sphere B. EA is the magnitude of the electric field at a distance of 0.04 meters from the center of charge A. Okay. By just looking at this graph, guys, we can see that When sphere A is just 0.04 meters away from the point charge, the electric field is like this, is over there, né? But when sphere B is at the same distance, the electric field is right there, which simply means that the charge on B must be greater than the charge on A. Are you together? Why? Because the electric field at a point is basically equals to Q all over R squared. If the distance is kept constant, and obviously K is a constant, for me to increase the electric field, that means the charge must be increased. But it's fine. Let's see the questions. Use the graph to answer the following questions. State the proportionality between the magnitude of the electric field at a point and 1 over R squared. They are directly proportional. Please guys, please do not confuse the relationship between E as well as R squared. Né? They asked us the relationship between E and 1 over R squared. Are you together? They are directly proportional. The more this thing increases, the electric field also increases. There's direct proportionality. Direct proportionality. Okay, we are told that we are told to calculate the numerical value of the gradient. Calculate the electric field for due to charge A if the numerical value of the gradient of the graph is 680. Okay. The gradient of the graph, guys, is basically changing y over changing x, right? So that's basically E divided by 1 over R squared. Are you together? Which can be rewritten as E divided by 1 over R squared. Are you together? And hence E can be written as, and then this statement can be further written as E multiplied by R squared. If I change from divide to multiply, that means I must flip the term on the right hand side. Are you together? E multiplied by R squared is always equals to, remember that guys, our equation is always equals to KQ over R squared. That means E times R squared is always equals to K multiplied by the charge. Are you together? So if they give us the gradient, this is the magnitude of the gradient. Are you together, guys? So they are giving us the products of the constant, which is K, and the charge, and the charge of sphere A. They want us to find electric field. So what we'll basically do is to say electric field is basically KQ over R squared. KQ over R squared, that's 680 divided by 0.04 squared. And then our answer will simply be 680 divided by 0.04 squared. You'll simply get 425,000 newtons per coulomb. Newtons per coulomb. Okay, and then we are being asked now, how does the magnitude of the charge on sphere B compare to the magnitude of the charge on sphere A? Greater than, smaller than, or equal to? We've already established that, guys, né? That for the fact that at the same distance away from the point, sphere B, the electric field that will be experienced due to sphere B will be greater than that of sphere A. Né? If we are keeping the same distance, the distance is still 0.04. Obviously, these two will be constant. This simply means that electric field is directly proportional to the charge which is causing the electric field. Né? So if this thing is increased, that means the charge would have been increased. Are we together? And hence, the charge on sphere B should be greater than that of sphere A. Are we together? The charge is greater than. Why? Because the electric field was increased at the same distance. So that means the charge of B should have been greater than charge A. That's how, guys, you're supposed to tackle this question over there. I really hope the video helped you out. Thank you for your time.